Okay. So first off, I want to thank everybody
Just a
for coming.
minute, I will introduce you.
Oh, okay, sure.
Good afternoon and welcome you all for this very special seminar by Nicholas Rada, who is from the US Department of Agriculture with a specialization in economics and econometric analysis. And he has spent 3-4 days with us from 17th onwards and visited number of locations in Andhra, Telangana and Karnataka to see on the ground realities what all the drivers and what all the enabling factors for the changes or the impacts what are happening around. And we will be fortunate enough to listen from him today on evaluation of the research and education performance in Indian agricultural development. So we look forward to Nicholas talking with us and sharing his views, which will be quite good for us to understand the things which are happening and which we might not have noticed. So over to Nicholas.
Thank you, sir. So before we get into the research, I want to give you a little bit of background about my research program. You know, the focus I've had is on measuring and evaluating the drivers of total factor productivity growth in some of the rapidly emerging economies, the BRIC countries. And the idea is, from a US point of view, if there's going to be a production shock in any one of these large countries, we certainly want to know because that's going to influence global prices and therefore US consumers. So we want to figure out what is the rate of productivity growth, how productive is the country, and then what are the policy drivers that are pushing agricultural productivity growth. And we're finding different drivers among different countries, the most prominent being investments in public agricultural research. So the talk today will be a culmination of research I've done on India, focusing on specifically the national public investments in agricultural research and the role that public education has played. This is research I've done in concert with David Schimmelfang at the Economic Research Service. So I just want to thank you all for coming. It's good, appreciate it. So I'm going to be exploiting a state level data set of Indian agriculture. And a couple of points, we want to exploit the state level data to capture regional variation with an attempt to influence national policy. Because certain states separated in the year 2000, we're going to be talking about, say, Old Madhya Pradesh as the central region, or we're going to be talking about Old Uttar Pradesh or Old Bihar. So when we start getting into some of that regional dialogue, you know with what we're speaking. As we all know, India's agricultural policies have been, for a number of years, fairly regionally and commodity specific. That has been especially true with respect to investments in agricultural research and higher education. In particular, since the 1960s, there are substantial regional variations we're observing in this policy. For instance, the investments towards state agricultural universities in the east of the country have received about a fraction of what other regions are getting. If we want to look at state agricultural university and higher education research expenditures going back to the 1960s, we see substantial differences between those allocated to the north, west, and south of the country versus those allocated to the east or the central region. Now, each region contains a different number of states, so just strictly looking at a regional analysis is not going to give us that. But we can, if we break it down on a state average of expenditures, we can still see trajectory differences between those in the east and central and those in the rest of the country. However, so on the one hand, we have a policy attitude that has maintained its specific region and commodity focus, but we see that farm production patterns have changed quite dramatically in India. If we want to look at we're aggregating about 68 crops into 6 different commodity groups. And if we take an average in the 1980, 1984, 2004, 2008 periods and say of these groups which are contributing to agricultural production growth. We can see that in the early 80s, it was largely grains and animal products. And when we say animal products in this context, we're going to be largely talking about milk production, dairy. By the time we got to the mid 2000s, that had shifted dramatically, largely at the expense of grains, as well as pulses, with the rising share in horticultural crops and animal products. But within this national narrative, there's substantial regional variation. For instance, in the north, where we have an intensification of this grain irrigation fertilizer technology, they have maintained their portfolio in grains. Other regions have largely pushed out of grains as a source of growth. In the old Madhya Pradesh, it was oilseeds or the soybean boom. In the west, south, and even in the east of India, you're starting to see horticultural products as a driver of growth in these areas, as well as animal products, the milk production. So given what I would say is a rather inflexible policy and a changing output mix, the purpose of our research is to ask whether agricultural growth would have benefited from a more flexible regional policy. Could there have been a greater return to agricultural research and faster productivity growth had that been the case? So this is a historical analysis going back to the 1980s. Where are we getting the greatest return for investments in agricultural research? And where have we seen the highest total factor productivity growth? So in the effort of trying to keep this a little bit more condensed, I'm going to skip some of the returns to agricultural research measurement and background information. I'm also going to skip a little bit of the data. We're going to focus more on the motivation, some descriptive statistics. I want to give you what I hope is not too detailed of a model development, and then the results. And what we're going to focus on formal technical change. This is an expansion of the production possibilities, holding inputs fixed, driven strictly by investments in public national agricultural research. We want to look at the returns to that research on a regional basis. We want to look at how efficiency has changed, technical efficiency specifically. So as the production possibilities are shifting out, this technical change, as we will, how is the rest? How are the rest of the states faring relative to that expanding frontier? We want to look at total factor productivity growth and what are some of the policy effects on efficiency, or how did policy, strictly irrigation investments, education investments, how did they influence the average producing state? So what is total factor productivity? Agricultural productivity is a term that gets thrown around a lot and is largely correlated with yields. But first we want to start out with real output growth. We want to eliminate the effect of prices, because the value could be rising and that could be strictly a price effect, and that is not relevant to a productivity. You can differentiate real output growth into yield growth and area growth. Are you expanding the area you're producing on, or are you raising the amount of output you get for a given unit of land? Within yield growth, you can further differentiate between intensification, or more labor, more fertilizer per hectare, and the introduction of new technologies, or TFP growth. This is science-led production growth due to new technologies, better farm management practices, getting more from less. Your area growth, your input intensification, these are largely resource-led growth. You're just using more land, more fertilizer, more labor, more materials. And we want to focus on TFP growth because in the long run, this is the more sustainable source of growth. So I want to give you just some regional variation. At the top, I've got the states filtered by the region, all right? And these are mean, these are growth indexes. So in 1980, everything is based at 1, and we're going to see who has seen the greatest growth. Now, there's a lot of information here, and here's a little bit of information on the data itself. But I want to direct your attention specifically to Old Madhya Pradesh. Because when you look at descriptive statistics, you want to be able to say, all right, from this, what do we think is driving agricultural productivity growth? Who has the greatest growth? So we can look at here and we can say, okay, old MP had the greatest output growth. However, relative to other regions, it also had the greatest input growth. And we want to contrast that with, say, the South, which had the lowest output growth among regions. However, it also had the lowest input growth. So based on that alone, it would be very difficult to say which region had the best agricultural performance over this period. We also have some policy variables. We want to account for rainfall. We want to account for road densities, investments in agricultural research, irrigation, and schooling. And here we see substantial variations with respect to infrastructure and rainfall, as well as to investments in research and education. All right, so we know just from looking at the descriptive statistics, we're seeing substantial regional variation. So we feel pretty good about moving forward, all right? And our purpose is to regionally evaluate India's public agricultural research and higher education investments. Now, federal funding to a given state ag university depends largely on its connection with national priorities. Since 1960, as I've shown, research investments have been much deeper in the North, West, and South. And since the late 1990s, we find the majority of the research institutes themselves have been concentrated in the North and the South of the country. And all of these are going to have influence and implications on the outcomes we're evaluating. For instance, in the mid-1980s, there were about 26 SAUs, 55 in 2012, and 63 in 2015. So we have a proliferation of universities, which largely is just a reorganization. You're trying to raise the profile of some of the smaller disciplines that were not getting it. However, at the same time, we're also seeing a decrease in the investments to these universities. So you're increasing the responsibilities, but then you're taking away the funding and decreasing the number of scientists as well. So that is an inherent problem as well. So how are we going to model this, all right? So as an economist, I'm going to use econometrics. So what we're going to look at is we're going to have a production function where we're going to try and relate the growth in gross output with conventional inputs, land, labor, capital, materials, policy variables. Beta is what we're going to be estimating, our estimated coefficients, and our error term. Now, when you use a general econometric method, it's called ordinary least squares or some variation of it, you're kind of shooting an average. What's the average effect of these? What's the average correlation of these variables? Are there anyone here that uses econometrics in their work? Any show of hands? Yes, some. Is there anyone here that's aware of stochastic frontier estimation? Okay, we have one, maybe two, all right? So an error term on a general OOS is going to shoot the average, all right? What we want to do is we want to decompose that error term and say, what's the states driving the frontier, all right? So to do that, we can decompose it into an idiosyncratic error. This is our common error term, and an inefficiency error. This is a one-sided inefficiency error, and what it does is it's capturing relative productivity. So stochastic frontier is not going to shoot the average, all right? It's going to go out onto the frontier of the data set and then measure the distance of each performance to that frontier. So it's giving you this relative measure of performance, all right? Now, this is the log likelihood function that Stata actually estimates, and this is not really something I want to focus on too deeply. But I do want to note that you see these terms here, and that term there, and there, and there, and there. These are the error term and the variances of our decomposed error, all right? Now, Stata is going to assume that all of your variances are homoscedastic, all right? So it's going to put in a constant. So it's going to say every state has the same production variance. And we all know that's not accurate, right? And what we want to do is we want to introduce heteroscedasticity into this model. And we're going to do that by scaling the variance of each error term, right? So we want to be able to say these errors are not homoscedastic. Not every state has the same production variance. We're going to introduce that into our model, and we're going to do that through these functions, all right? This is our idiosyncratic error. It's going to be a function of rainfall, because we want to introduce that into the model. Here's our inefficiency error, and we're going to make that a function of L policy variables, education, irrigation. So we're going to introduce that, and by doing that, well, before I get there, so this is our technology function. This is what's going to determine where that frontier is and what is the relationship between. We're going to do that by estimating. We're going to specify it as a generalized Cobb-Douglas where we have our production inputs. We want to account for the role of rainfall in production. We want to account for the role of transportation roads. And we want to account for agricultural research investments. Now, we're going to take a regionally flexible model, all right? So we're going to have different parameter estimates for each region, and we want to do it, and this is our source of formal technical change. This is going to tell us how much the production possibility is expanding differently by region while holding inputs fixed. So it's the technical change induced by public investments in agricultural research. Now here is our idiosyncratic error variance model. We're going to scale that by rainfall. We're going to introduce that heteroscedasticity by accounting for the rainfall variations. We also want to express our inefficiency function as a function of well irrigation, canal irrigation, and lower education schooling investments. Now again, we're going to take a regionally flexible model with public education. Why? Because the state agricultural universities, the investments to research capture not only investments to public research, but higher education. So in taking this framework, we're able to regionally focus on both lower and higher education and its implications on efficiency and total factor productivity. We're going to estimate technical efficiency as the expected value of this inefficiency error, conditioned on the composed error, but because we've introduced variables into this error term, we now can determine what is the effect of a 1% increase of that variable on mean efficiency. All right. Now, for those of you who use Stata, stochastic frontiers, know that these variance functions they're not really variance functions, they're standard deviation functions. Because when you have a one-sided error term, the variance and the mean are going to shift together, all right? So what it's doing effectively is doubling all the values on that standard deviation. So you can use a variance function and impute the effect on the mean of efficiency, all right? Now you could look into one of these standard packages and you can say, hey, you can put your variables in your mean function or in your variance function, but it's important to introduce that scaling effect to your variance function, to introduce that heteroscedasticity to ensure you have unbiased parameter estimate. And in doing so, you can look at the effect of policy on mean efficiency, or how does policy affect the relative productivity of the average relative to those best practice producers. I hope that wasn't too bad. We're going to start out with some basic specification tests, okay? How do we know what we're doing is correct? Well, we're going to start by looking at the one-sided error term, all right? We know it's one-sided, but how is it distributed? We have to assume a distribution on that. We're going to test 3 different distributions. We also want to test whether our variances need to be scaled. Okay, so if anyone were to use Stata and estimate a stochastic frontier, you would go down and you would see a constant. And if that constant is statistically significant, that's the first bell in your head saying, okay, this has a heteroscedastic and we can introduce some information in there. But we're going to run a couple of tests on that to make sure that we're specifying this model correctly. So again, a lot of information, don't worry about it. What we're looking at the top are just some log likelihood ratio tests. So what we want to know is that inefficiency variance function homoscedastic or heteroscedastic? Is the idiosyncratic variance homoscedastic or heteroscedastic? And jointly, which are they? And we can also run parameter tests. which of those are those, if you put in variables into your variance function and it's not statistically significant, then it's telling you that, maybe your production variances are homoscedastic, so you can run with the regular model. But if you find it's heteroscedastic, if you find this variation in your variances, then you need to model it to get unbiased parameter estimates. And lo and behold, all of these statistical tests are saying, yes, you have a heteroscedastic model, so you're safe to move forward. So far, you're specifying your model correctly. Okay, so to get to our first result, I'm making good time, so maybe I shouldn't have cut out so much. We want to look first at the per annum rate of agricultural formal technical change. So again, this is the production possibilities expansion, holding inputs fixed, induced strictly by investments in public agricultural research of the national research system. And what we're finding is that the North had the highest formal technical change. The West regional slope parameter was not statistically significantly different. So the model is saying, hey, I can't see any difference between the effect of the West and the North. However, we can find a substantial difference between the North and the East. That is to say, if we increase the stock of agricultural public research and higher education investments in the North, we can expand the production possibilities frontier by 0.26%. If you similarly increase by 1% the stock of research investments in the East, you're only getting a 0.08% expansion in technical change, or expansion of that production possibilities frontier. Now, by and large, all of these numbers are quite low. Now, I think it's important to note at this time that from previous studies, it's very clear that as a singular policy investment, the public agricultural research investments have the greatest effect on boosting TFP. As a marginal effect, you're going to get the greatest impact by investing in R&D. But yet we're still finding, as a contribution to overall total factor productivity growth, it has not been as great as what we would like. All right. So now we have a sense of the contribution of R&D to technical change, to expanding this production possibilities of these best practice producers. So we want to look at rates of return. So what is the rate of return to these investments in agricultural research? Now, the first column here, all right, you need three bits of information to estimate a rate of return, all right? You need to know what is the elasticity between research and productivity, which is what we estimated in the previous table. We need to know how those research investments, what is the lifespan of those research investments? How long does $1 in research last? How many years, all right? It's not a one-off. Any 1 year investment in agricultural research is going to have a lifespan that we found of about 18 years, all right? So if we look at the internal rate of return, we're finding, well, let me first explain the difference between an internal rate of return, a modified internal rate of return, and a benefit cost ratio. And this was one of the slides I cut out, so I apologize. The internal rate of return is the typical standard measure for rates of return in agricultural economics. But it also assumes that all of the benefits that are generated are reinvested at that same rate over the lifespan of the project, all right? Now, there's been some debate in the literature over whether that's accurate. Should we not instead be discounting the amount that could be invested? So there should be a reinvestment rate. And there's a little bit of debate in the literature about which is more accurate, the internal rate of return or the modified internal rate of return. Modified internal rate of return comes from the business literature, where you might have different lifespans. And you'll see that the modified internal rate of return is a little bit sensitive to the change in lifespan. So you've got some trade-offs, all right, between these two measures. And then the benefit cost ratio. Yet, despite these three measures, we're seeing a common trend, all right? We've got two allocation scenarios. Because we're looking at a regional analysis, and say the central region is by itself, we first want to say if we allocate all of the research expenditures at the state level, what's the rate of return? And then if we were to allocate it at the regional level, what's the return? So it's just sensitivity tests. And what we're finding is regardless of the sensitivity test, regardless of the measure used, the North is having by far the highest rate of return. And this is in contrast to the East. And we can see the rate of return in the East is about half that, if not far less than what you're getting in the North. And I think this would be largely what you would expect when you look at the differences in the investment portfolio across regions. So we have our formal technical change. Now, if you want to get total factor productivity growth, you have to account for expansion of the production possibilities as well as the production of everybody else, so the performance of everybody else relative to them. So we call that mean technical efficiency change. And we can find that the mean efficiency change was actually highest in the South. That is, producers in the South were able to shift out their production possibilities. Those average performers were able to shift out at a higher rate towards that expanding frontier faster than everybody else. And that's in contrast to the West, which had by far the lowest. All right? Now, typically, if you have great growth, you're going to expect a decreasing value. You're going to expect that difference between the best production practice and the average production practice to widen over time. Now, in this case, because we have had less than robust production possibility or technical change, we're seeing that the average producers are actually shifting towards that frontier, which is not very common in the literature. So when we add the two together, we're finding rates of productivity growth of less than 0.6% that are highest in the South, Central region, and lowest in the East. And these are per annum rates. So these are the increases in the output growth once you hold inputs fixed. So we're going to sum this regional technical change. We're going to weight by regional revenue shares to account for the difference in the value of production in each. And we're getting about 0.21% per year. And we're going to sum our efficiency change over regions, again, weighting by revenue shares, and we're going to get about 0.24% per year. So we're going to find only about 0.5% per year of total factor productivity growth. Now, this is extremely low. Generally, for an emerging economy, for a developing economy, you would want around 2% growth per year to ensure that you're pushing your agricultural sector along. Now, this is much lower than the close to 2% rate that I estimated with these same data in my earlier paper. This is much closer to Ramesh Chand et al.'s 2014 estimate of 0.28%. Now, they use cost of production data, which generally is higher quality, but accounts for fewer commodities. One of the benefits of our analysis is that we're capturing 68 commodities. We're capturing those high value sectors, the horticulture and the dairy, all right? However, if we go back and originally start over our model and we take out our R&D term and we put in a time trend, which is the generic estimate of technical change, we're going to get 1.93%, all right? So what that's telling us, what is that telling us? That's going to say, yes, R&D has had effects, but the bulk of growth is coming from other factors, coming from private research, could be international research, it could be learning by doing, it could be all these other unmeasurables that are really not R&D related, at least not national R&D related. So what are the factors that have been pushing up all these other factors? All right, so we know a lot's going on in Indian agriculture, and not all of it is R&D led from the public's national research. Well, we're finding well irrigation. So for every 1% increase in the area equipped with well irrigation, we're seeing about a 0.06% increase in efficiency. So we're able to lift up that average performance through well irrigation. But we're seeing significant differences on the role of lower education investments. All right. Here, we're getting very low responses. Here, we're getting much higher responses. So for every 1 year increase in primary education, we're able to increase the performance of the average relative to those best practice producers by about 1.3%. So to take a step back, this is saying if I were to look at two policies, well irrigation or public investments, and which is going to be boosting farm performance, I would be looking at primary education or investing in agricultural education, public education. So in conclusion, we find that the greatest return since the 1980s would have been redistributing the research investments to the north, less so to the west and south, and even less to the east. Now, the success of the north, it's likely explained by the high adoption of the research outcomes. The grain, fertilizer, irrigation production technology that is predominant there, and the research that's being done has supported those. So the farmers are adopting those production technologies. This could be, say, in contrast to the east, where we suspect there's poor integration between research priorities and farmer adoption of technologies. Marketing opportunities, for some reason, farmers in the east are being discouraged from taking up the production technologies that are being developed by the public research institutes. The farmers in the south who have been able to expand their technical change or this best practice performance at a similar rate to the north have also enjoyed the greatest efficiency improvements and have given them the highest total factor productivity growth. So it's not so much a shift from growth of the best practice, but it's from lifting the performance of everybody else as well. They have a combination of both effects going on. So there's clearly something that's going on in the South, despite their relatively lower output growth, that has led to improved performances among those producers relative to the rest of the country. So overall, technical progress and productivity growth easily attributable to the national research system has been low. The bulk of growth has come from other factors: irrigation, education, new output mixes, and learning by doing. So that is the bulk of it. So thank you very much for your time. I appreciate it.
Topic is open for discussion.
It's good. It's after lunch. Everybody's very tired. I understand. No worries.
If you also take into consideration the risks involved in the east, a lot of floods, more risk. The south, risk is less. Environmental risk.
Environmental risk.
And how can you predict using this model the future in the scenario of climate change? And it will be.
So, accounting for production risk, we did our best to account in our land measure, say the differences between, say, irrigated versus rain-fed agriculture, but production risk not so much. You know, this is because we're using state aggregated data. I think a lot of these factors are very hard. So I liken using these data sets to using a very fat paintbrush, okay? I want to paint a pretty picture, and I'm using a pretty fat paintbrush. Now, if I had household level data with very detailed data, say, pertaining to agricultural production risk, you would have a very fine paintbrush, and you would paint a more beautiful picture. But standing back, you can see the same picture. You can see the same image. So no, we're not able to account for it, but I think we're still able to capture the same story should we have those data. They're being captured there. And your second question? The projecting. So this is all a historical analysis. I would be hesitant to use these data to project future productivity performance without additional variables, because I think a lot of the climate change impacts on production performance are likely a within 10-year effect that they're starting to bite on farmers. When we look 20, 30 years back, I don't get a sense from the data that it's as critical to the analysis. Moving forward, yes, these are things that increasingly need to be accounted for in any productivity analysis. And I think for that reason, it was critical to try and capture the production variance, which in a way is kind of risk related, that occurs over states and that we modeled through rainfall. So to some extent, we're starting to scratch the surface of that, but I would not really say it's sufficient for what we would all expect and what we would like.
David?
Yeah, just so with the investment in research or education, and I guess given that you're painting with a very broad brush, we'd really be interested to know what data we need to better understand how to make the education research system even more efficient. So making the investment is one thing, making a more efficient approach for investment is another. Any thoughts on that? And maybe while you're thinking about it also, that we have this village level dynamic data, and how can that be used to paint with a finer brush some of these issues?
Sure. I think I was concentrating on your second question and I lost your first question. All right, so we know that we're getting the highest rate of return in the north, all right? So why is that? Is it because you have the proliferation of research institutes? Is it because they're focusing on research outcomes that those farmers want to adopt? So I think there's an aspect there that needs to be dealt with. Okay, you have policies that have been pushing certain crops and certain research priorities, and those have clearly benefited some regions more than others. So on a regional, on a national scale, I think there needs to be recognition of this. Now, whether this is, okay, you need to stop investing in the east and start investing in the north, but have those scientists start working on research outcomes that the east could uptake more readily. It might not go, it might go against my results a little bit to say, well, maybe you need to start moving all the research institutes to the east because there's certain human capital that's associated with these research institutes and the regions around it get the benefits of that. Would using village level data improve the analysis? I think certainly. I think there could be some benefit to getting a smaller brushstroke and trying to understand how this all could be benefited from. But that's the $1 million question, right? Like it's a tough one. It's unclear to me at this point in time what would be the best option, because I think the status quo policy agenda is, I don't get the sense that that is changing. So given that and steady investment in these primary crops in these regions, what's the best option? If you just want to strictly talk about, all right, how do you raise your rate of return statistically? You just stop investing in the east and you throw your money in the north. Now, is that going to provide the best benefit to farmers? Probably not. That's why I think, possibly focusing more on the research outcomes and what are the research outputs that the farmers want to adopt. There needs to be a little bit more of that integration for those farmers in the east. But then, of course, there's also the marketing aspect, right? I mean, there's a whole lot of other things going on besides strictly research investments. But from this analysis, there has to be something change. There has to be some give here. And the two things I keep thinking back is, well, if you had institutes there and the human capital, then you would start to get probably a little bit more movement. Or you might need to get the strong research priorities in the north more focused on the opportunities in the East. I'm sure that's not the answer you're looking for, but that's the one I can give at the moment.
Yeah, in terms of methodology, and you have done quite a good analysis. But as I think some of the answers you have given partly in answering some of the questions, the implications of your results is very tricky to really use. You say that, as you said in the lastly, as a state simple, if you redistribute to north, the returns are very high. But today the government really focuses on east, because now government for last few years is really focusing for increasing investment in east, where we see that higher potential of growth, which is opposite to what you have come up with. And the data which you are using, I think you are using from 1980s. So also if you look at the 60s and 70s, there might be a possibility that there was higher investment in the north already. So awareness level, knowledge level, and the minimum start level was there in north. It was not there in the east. So the rate of growth couldn't pick up in the east because the minimum was not there. North already had, starting from Punjab and Haryana in 16 and 70. So it's a bit complex. The method is very good, but I think these things are, we need to look at many things. And market, as you said, again.
Fair enough. Fair enough. You know, this story is a narrative I was told many times when I first came to India a number of years ago. Regional variation. We want to shift the production the grain, fertilizer, irrigation technology to the east. Right? That's the goal, because we have water resources there. We might not have the infrastructure, but that can be built. Right? So when I thought, okay, well, let's empirically look at this question. Right? Yes, they may have started from a higher level in the north, but the research investments, what we're capturing, go back to the 1960s. This is a stock of research. We call it knowledge capital. So yes, we have more knowledge capital in the north as they're focusing on those issues, right? But we can clearly see that yes, they're getting a high rate of return, but we're not seeing the shift in the research priorities to meet the needs of the farmers. You're seeing the growth and productivity coming from those areas that are not responding to those research investments. It's not the primary crops, it's the horticulture, it's the animal products that are giving a lot of the productivity growth in these other regions. And that, you know, accounting for more outputs than generally has been done, trying to see where that growth is. I think these are, you know, it's baby steps, but I think these were the first baby steps that need to be taken to get that message out and saying that narrative that we all talk about is empirically founded, right? There's validity to it. Now, how do we jumpstart the East? Is there potential there? That's different. That's forward looking, right? This is looking historical, what has happened and why. And I think that's more the focus of, say, this type of analysis than trying to project the future outcomes. But you can use this knowledge to think forward and say, what needs to be done to try and stimulate the East? What have we learned from the North, the West, the South that could be used to stimulate performance in the East? And that's more kind of the basis for what we're working with. The change in commodity mix is a big deal. The lack of change in policy is a big deal. I think those things are national policies that could influence local production possibilities in the East. Now, again, state level data, hard to really account for, say, agroecological differences, soil differences. You know, there's a lot going on here that's being obscured, but there's only so much you have to start somewhere, and you can't trying to start somewhere that makes sense and tells a good narrative. But you know, to some extent, I think you're right. There's definitely constraints to what this type of analysis can offer.
Kind of naive question. Has your model taken into consideration of this per capita farmland for the east versus the rest of the regions?
So relative population densities.
Not per se. I mean, I'm asking per capita availability of farmland.
So sure, you know, we're capturing the available farmland in each state, and then looking at regional variations. So we try and differentiate between the productivity potential of, say, irrigated cropland versus rain-fed cropland versus pasture land. But because we're capturing the total amount of land in each, quality, accounting for relative quality differences in a single measure, I think we're capturing that. Now, are you thinking as a constraint?
Yeah, are you taking population as well into consideration while you take the total farmland in when you take that into account?
So the population, say, density of a given state has not been included in the model.
Mm-hmm.
It could be. Okay. So first off, I want to thank everybody for coming.
I will introduce you.
Oh, okay, sure.
Good afternoon and welcome you all for this very special seminar by Nicholas Rada, who is from the US Department of Agriculture with a specialization in economics and econometric analysis. And he has spent 3-4 days with us from 17th onwards and visited number of locations in Andhra, Telangana and Karnataka to see on the ground realities what all the drivers and what all the enabling factors for the changes or the impacts what are happening around. And we will be fortunate enough to listen from him today on evaluation of the research and education performance in Indian agricultural development. So we look forward to Nicholas talking with us and sharing his views, which will be quite good for us to understand the things which are happening and which we might not have noticed. So over to Nicholas.
Thank you, sir. So before we get into the research, I want to give you a little bit of background about my research program. You know, the focus I've had is on measuring and evaluating the drivers of total factor productivity growth in some of the rapidly emerging economies, the BRIC countries. And the idea is, from a US point of view, if there's going to be a production shock in any one of these large countries, we certainly want to know because that's going to influence global prices and therefore US consumers. So we want to figure out what is the rate of productivity growth, how productive is the country, and then what are the policy drivers that are pushing agricultural productivity growth. And we're finding different drivers among different countries, the most prominent being investments in public agricultural research. So the talk today will be a culmination of research I've done on India, focusing on specifically the national public investments in agricultural research and the role that public education has played. This is research I've done in concert with David Schimmelfang at the Economic Research Service. Yeah, so I just want to thank you all for coming. It's good, appreciate it. So I'm going to be exploiting a state level data set of Indian agriculture. And a couple of points, we want to exploit the state level data to capture regional variation with an attempt to influence national policy. Because certain states separated in the year 2000, we're going to be talking about, say, Old Madhya Pradesh as the central region, or we're going to be talking about Old Uttar Pradesh or Old Bihar. So when we start getting into some of that regional dialogue, you know with what we're speaking. As we all know, India's agricultural policies have been, for a number of years, fairly regionally and commodity specific. That has been especially true with respect to investments in agricultural research and higher education. In particular, since the 1960s, there are substantial regional variations we're observing in this policy. For instance, the investments towards state agricultural universities in the east of the country have received about a fraction of what other regions are getting. If we want to look at state agricultural university and higher education